Hello everyone, this is Professor Keen. Today I want to talk about Mueschenbroek's wonderful bottle. Again, this is from A Student's Guide to the Great Physics Texts, Volume 3, Chapter 4. Today we'll be talking about Franklin's 1748 letter to Mr. Peter Collinson, where he describes his experiments with the glass bottle, the Mueschenbroek bottle. Specifically, he's interested in the question of where does the electrical fire reside in this glass bottle. So let me write that down, and then we will explore the answer to this question. So here's the question: where in the glass bottle, or the Mueschenbroek bottle, or the Leyden jar, I'll write the Leyden jar, where in the Leyden jar is the electrical fire stored? Right? So what he had done, we talked about this in the last couple of lectures, is he could take this glass jar with a cork in it and a metal wire sticking out of the top, and he could charge it up. It was full of water, by the way. He could charge it up and then receive a shock from it. So the question is, where specifically in this jar is this electrical fire or this electrification stored? So what he does in this fourth letter, he describes a number of experiments that he carries out to try to answer this question. This is a bit like reading a murder mystery, right? So he's trying to eliminate possibilities. So let's talk about how he answers this question. By the way, you'll see in this letter 4 right here, what he does is he, first of all, in the first few points, is he summarizes the results. And then in point 17, down here, what he does is explains why he thinks that that is the result. So I'm going to jump right away to 17 and the experiments he carries out. So first thing he does is he electrifies the bottle as before. So he electrifies the bottle. He places it on a piece of glass on the table. This is presumably to insulate it. So this is for insulation. Let me get rid of this. He placed it on the glass, and then since he's electrified it, placed it on the glass, now he removes the cork and the wire. The cork and the wire from the bottle. So maybe if you remember how this works, you've got this bottle like this, and the top of it there's a cork sticking out, and there's the wire with the little metal ball. The wire sticks down through, and then inside of the bottle there's water. Right, that's the setup. So he electrifies it, and then he removes the cork and the wire. He pulls those out. And this is the important point. He notices that even having set this aside, he brings his finger near the mouth of the bottle, and he still receives a shock. A spark or a shock from the mouth of the bottle. And so what does this imply? Well, the implication, of course, is that the electrification does not reside, in the cork and wire. If it was, when he took it out, it should be removed, right? So he's eliminated that possibility. Well, let's try another experiment, he says. This is once again down here in paragraph labeled number 17. He once again electrifies the bottle. He places it on glass. Well, actually, before he places it on the glass, what he does, I think what he says, is he removes the cork and wire. Let me go back a step. He removes the cork and wire, and then he decants the water into a separate bottle. He decants the water, that is, he pours it out into a separate bottle, a second nice clean bottle. Okay, and both bottles are placed on glass. The old bottle that had been charged up, and the new bottle containing this decanted water. These both bottles are placed on glass. Okay, and then what he does is he touches the mouth of the second bottle, and he notices that he gets no shock from the second bottle. this new bottle containing the decanted water, right? And then, so somehow this water that had been transferred from one bottle to the other did not carry this electrification with it. Well, so where did this electrification go? Where is it? Well, he refills his first bottle. He refills the first bottle with clean water from, he says, from a teapot. And then he notices that he still receives a shock from the first bottle. So he tried to reproduce. He poured out the water that might have carried electrification into the second bottle, didn't get a shock, refilled the first bottle with water, and he gets a shock from the first bottle. So somehow, he says, that implies that the electrification is not stored in the water. And by process of elimination, if it's not in the cork, not in the wire, not in the water, he deduces that the electrification must be stored in the glass itself. In the glass itself. Okay? So this is how he determines this. He does a few more interesting experiments then. So let's go on. This is, I think this is still in paragraph 17, but it might go on. Let me see if I click over here. Yeah, paragraph 17 is where he's still discussing this. So let's talk about his next set of experiments. Now he says, okay, if it's in the glass, does it depend on the shape of the glass? Does it have to be a glass bottle? Well, what he can do, or what he did, is instead of a glass bottle, he took a piece of plate glass. So like a window pane instead. So this is some plate glass that he uses instead. And then what he does is he attaches a lead plate. Lead, presumably because it's nice and malleable, you can kind of hammer it into thin layers and spread it across the glass. He has this lead plate that he places on it. So here's our lead plate. And what he does is he, uses some kind of device in order to charge up this lead plate. And he actually, I think he says he puts a lead plate on the bottom as well. He sets this down on his table. He charges up this lead plate, then takes the lead plate off, and he touches the glass. And he notices that he receives a small shock when he touches the glass at this point or at this point. So he receives a small shock after electrifying the lead plate, then removing the plate when touching the glass. So that wasn't a real easy to read sentence, but he receives a small shock after he electrifies the lead plate, removes the plate, touches the glass, then he gets a small shock. Okay, this is kind of like here, using this metal wire to electrify this glass, removing this wire, and then getting shocked by the glass. Same thing, he has a lead plate, he electrifies this, takes the lead plate off, he touches the glass, he gets a small shock. And it's a small shock, he says, and he touches at various points on the glass and gets small shocks from all over the glass, from different positions when touching the glass. So somehow this electrification is being stored on the surface of the glass at different positions all over it. And then what he does is he leaves the lead, he charges it up with the lead plate, leaves these lead plates on, and then touches the lead plate, and he gets a large shock. Receives a large shock if the lead plate is left on the glass. And he deduces that this electrification is stored on the glass, and the lead plate is able to, in a sense, collect it from all different regions. So if I were to draw a little picture here, I'm running out of space, I'll probably have to stop this lecture. But you might imagine that there's all kinds of charge. I'll write little positive numbers here, positive symbols. there's charge being stored all over the surface. There's actually negative charge. I'll talk more about this in my next lecture, but there's positive and negative charge being stored on the opposite sides of the glass. And when he touches some location, he's receiving the spark from this electrification stored at this position or this position or this position. But the charges, because this is insulating, can't slide along the surface very easily to produce a big spark. But if he places this lead plate over it, then you touch the lead plate, not only the charge from this side, but the charge from the entire surface can flow along the lead plate and provide the spark. So in a sense, the lead plate, he says, arms the glass and allows the charges that are stored on the surface of the glass to be all collected and produce a large shock. Okay, so we'll talk about this a little bit more next time. We'll talk about capacitors and capacitance, because in effect what Franklin has done here is he's created the first parallel plate capacitor, which is some kind of metal plate, another metal plate, and an insulating material sandwiched between them. So why don't we stop there, and we'll come back to this next time.